an absolute value inequality, problem type 5. So at this point, hopefully you have made it through problem types 1 through 4 and watched my videos for those. If you haven't, you might be a bit lost in this video. I'm going to give a really brief recap, but if this isn't enough, please go back and look at problem types 1, 2, 3, and 4. So as a brief recap, when we have absolute values, only when there's these up and down lines, we need to do special things with inequalities. So if you have an absolute value that's less than a positive number, it's important that this is positive. If it's less than a positive number, you sandwich whatever is inside the absolute value between the negative version of this number and the positive version of this number. And then you solve this 3-part inequality, which we call a compound inequality. If you have a greater than sign, so take note that this has nothing to do with the underlines and everything to do with the direction that it's pointed. So that's a less than sign. This is a greater than sign. If you have a greater than sign and you have a positive number, this is going to split into, it's going to split into 2 different inequalities. The first one is the original one without the up and down lines, so without the absolute value, or you're going to have the same stuff that's inside, less than, so switch that direction, less than the negative version of this number, and then you would solve from there. The 2 special cases, if you have an absolute value that's less than a negative number, like you have stuff in here and it's less than negative 10, you're not going to have any solution at all because these are positive numbers. Positives cannot be less than a negative. If you have an absolute value is greater than a negative number, like the absolute value of whatever is greater than negative 10, then all positive numbers are greater than all negative numbers, so your answer is going to be all real numbers. So just kind of keep that in mind as we go through these problems. Let's get started. So this problem is going to ask you for just the inequality answer, but since on the exam, and you've heard me say this, I'm sure, at this point, on the exam we're asking for interval notation and the number line answer, so I'm having you do both in this video so that you're exposed to it. So before we can solve this guy, before we can either split or sandwich him, we have to get just the absolute value by himself. We cannot do anything while this +8 is here and this 7 is here. So we start just like we would if we were solving a linear equation. We're going to get rid of anything that's added or subtracted on the outside first. So we have 7, absolute value of w plus 5 is greater than 42. Now we need to get rid of this 7 on the outside. To do that, you divide this whole thing by 7, which will cancel those 7s out. And we have the absolute value of w plus 5 is greater than 6. Because we have a greater than sign, this is a greater than sign, and the absolute value is all alone, and this is a positive number, greater than sign means we split into 2 inequalities. So I'm going to split this over here. We have w plus 5 is greater than 6, and then our other one is w plus 5 is less than negative 6. And these are separated with an or, and that's really important. Move that here. It's really important that you, didn't mean to do that, that you have that or, not on the exams, that's not as important. It's more important on ALEKS. I keep on switching things. On ALEKS, it's important because they're going to ask you to answer with, there's a button for an and there's a button for or. Don't worry about the ands. You don't need to deal with that, but the or one happens when you split. Right, so I'm going to get w by itself here. So subtracting 5 on both sides. So I have w is greater than 1, or subtracting 5 on both sides, w is less than negative 11. So on ALEKS, what you'll be answering is w greater than 1 or w less than negative 11. That will be the answer that they're looking for. But to satisfy the test requirements, you're going to need to graph it and do interval notation. So remember, if you do not have an underline on your inequality, those are going to be open circles on the number line and parentheses in interval notation. If you do have those underlines, Those will be closed circles on the number line, and brackets in interval notation. Here we had no underline, so we will have open circles. If you split, that means that you will be shading the tails. You'll be shading two different pieces. This is the W less than negative 11 part, and this is the W greater than 1 part. You'll be shading those parts. Down here, negative infinity. Up here, positive infinity. So the interval notation is negative infinity to negative 11, parenthesis. Then there's a blank spot, so we'll put a union symbol, and 1 to infinity. And that is the interval notation answer for this problem. Let's go look at another. All right, similar type situation. We have this addition out here and this number on the outside of the absolute value. We have to get the absolute value by itself to begin with. So we're going to do minus 8, minus 8. And then we have 5 absolute value of u plus 6 is less than negative 20. I can already feel something uncomfortable happening because I see a negative number over here. But let's go a little further. So we divide by 5, so these 5's cancel. And then we have the absolute value of u plus 6 is less than negative 4. When you have a negative over here, you are looking at a situation where either the answer is that there's no answer or that everything is an answer. Positive numbers cannot be less than negative numbers. That doesn't make sense. So no matter what I plug in for u, this thing is going to be positive, or the smallest this could be is 0, but 0 is not less than negative 4. So on this guy here, there's no solution. There's no number line graph to give, there's no interval notation answer, there's just no solution on it. So let's look at another one. All right, same idea. We want to get rid of this minus 3 first to get the absolute value by itself. So I'm going to be adding 3 to both sides. We have the absolute value of 4u plus 2 is less than or equal to 10. This is a positive number, so we're good. The absolute value is all by itself. There's nothing else around it. And this is a less than sign. If you have a less than sign, you're going to sandwich between negative 10 and positive 10. And you're sandwiching all of the stuff in the center. So we have negative 10 less than or equal to 4u plus 2 less than or equal to positive 10. So I have underlines on these because the original had the underlines. And notice that I kept everything in the center the same. In order to get u by itself, we have to, this is a compound inequality, we have to treat it like we have 3 sides of an equation almost. So anything we do to one part, we do to all 3 parts. To get u by itself, I want to be able to subtract 2 from all sides. Here we have negative 12 less than or equal to 4u less than or equal to 8. To get the u by itself, I need to divide by 4. So I will do that to all 3 pieces. I have negative 3 is less than or equal to u less than or equal to 2. Now what's really nice is that your interval notation, when you have this compound inequality, it just pops right out. So the underlines mean brackets. So you have bracket negative 3 to 2. That's your interval notation. That's the answer for the interval. So on the number line, if you have the sandwich, the 3-parter, that means you're shading the inside. So kind of you can think u is in the center, so we shade the center. I'm going to put closed circles on negative 3 and 2. And then I'm shading that center part there. On Alex, so the answer on the test we're looking for, this guy and this guy. On Alex, they are looking for this answer right here. So you can enter it just like this on the computer. If you go to their explanation, they're going to give you they might give you a different explanation that involves the use of and. I wouldn't concern yourself with that. The only thing you need to worry about is the or, and that's only if you split. So I have a few more examples just to make sure you've seen enough of them. We have this guy. The absolute value of 4x plus 18 is greater than or equal to 25. We want to get this guy by himself, so we'll start with getting rid of the 18. So the absolute value of 4x is greater than or equal to 7. Right? And we have the absolute value by itself, positive number over here. This is not going to turn out to be a nice number, but that's okay. Absolute value by itself, positive number, and this is a greater than sign. So a greater than sign means that we are going to split the inequality. The stuff on the inside, without the absolute value signs, right, just the stuff on the inside, is greater than or equal to 7. So this is the original one without the lines. And then the second one, 4x, change the direction, make the number negative. On both of these, you're going to be dividing by 4 on both sides. Here you're going to have x is greater than or equal to 7/4. Over here, x is less than or equal to negative 7/4. And there's an or in between them. So when you've split into 2, that means you're shading 2 spots on the number line. Negative 7/4 is down here, positive 7/4 is up here. We had underlines, so these will be closed circles. And then we're shading the tail portions here. So that's negative infinity, positive infinity. The interval notation answer here, negative infinity to negative 7/4, bracket, union 7/4 to infinity, and that's the interval notation for that. On ALEKS, they're looking for this answer here. Make sure it says or in between them and not and. So just one last example, and this one is going to go relatively quickly. It's actually, I think, nearly an identical situation to the one we had before. So we have 4 absolute value of w plus 6. We got rid of the 8. Greater than negative 20. And just like we had before on a previous problem, when you see that negative 20 over there and there's nothing left to add or subtract, you're just dividing, then it's looking like you have a special situation. If I divide by 4 on both sides, I get the absolute value of w plus 6 is greater than or equal to negative 5. All positive numbers, and this is a positive number, regardless of what you plug in for w, we're looking at positive numbers. All positive numbers are greater than all negative numbers. So here we're looking at all real numbers as solutions. And that's about it. I mean, you saw quite a few examples here. It's really a matter of knowing what to do here. If you know these 4 different scenarios, you're in good shape. The thing that we worry about is sometimes students think that every inequality is an absolute value inequality. If I gave you, just really quickly, just generate something on ALEKS real quick. If I gave you 3y minus 3 plus 4 less than 16, and there are no absolute values, none, there are no absolute values, you don't do anything special with this. So those parentheses aren't doing anything. I can combine these like terms. So I have 3y plus 1 is less than 16. I would subtract 1 on both sides. 3y is less than 15, and then I would divide by 3. Just solving it normally. You aren't going to split an inequality or sandwich an inequality unless there are absolute values. So you have to see those up and down bars in order to be in a situation where that's relevant. I want to point that out because I've seen students lose a lot of points on tests by treating every inequality like it's an absolute value. And not every inequality problem is an absolute value inequality problem. All right, that's all I have to say today. That's it for the absolute value inequalities. If you made it this far, you're doing great. If you have questions, you can always ask your instructor. And I hope you have a fantastic day and a great rest of studying for this material.